All right, Trig Homework 32 is all of Chapter 8. Chapter 8 I moved ahead because once I got in the middle of Chapter 7, it wanted you to do part of Chapter 8 back and forth. So we're going to do Chapter 8 before we do Chapter 7, but most of this should be stuff that you've seen many times before. First one here, we're just solving a system of equations using substitution. System of equations is when you have two equations and two variables. And if we have one of our variables solved for x or y, we can substitute into our other equation. So, rewriting the bottom equation, putting in the 3x minus 4 in place of the y. So I'm going to have 4x plus 3 times, and in place of the y, I'm going to put 3x minus 4 equals my 27. Now I have an equation that just has one variable that I can go ahead and solve. So 4x plus 9x minus 12 would equal 27. Combining my like terms, 13x minus 12 equals 27. Adding my 12, 13x equals 39. And of course my last step, dividing by my 13. X equals 3. So I found one of my answers, x equals 3. To find my y value, technically I could use either equation, but the top one's already solved for y, so that one, of course, is the easier one. Y is equal to 3 times my x value, which is also 3, so 3 times 3 minus 4. 3 times 3 is 9, 9 minus 4 is 5, so y equals 5. Now, if you weren't sure if you did that correctly, you can always check your answers in your other equation. So if I took 4 times my x value, which is 3, plus 3 times my y value, which is 5, do I get 27? Well, I would get 12 plus 15, which is 27. So yes, it checks out. Hopefully I know, yep, I did it right. So on number 2, we are solving our system of equations by substitution. Notice on this one, our bottom equation is solved for x. So I'm going to replace the x in the top equation with the 3y minus 18 that x is equal to. So rewriting my top equation, I'm going to have 5 times 3y minus 18 plus my 4y equals 5. Now my equation just has one variable. I can go ahead and solve that. 5 times 3y would be 15y. 5 times negative 18 would be minus 90. Plus 4y equals 5. Combining my like terms, 15y plus 4y would be 19y minus 90 equals 5. I would go ahead and add my 90. So 19y equals 95. And then I have to divide by 19. 95 divided by 19 is 5. So y is equal to 5. Again, I want to find my x. I could use either equation, but my bottom equation is already solved for x. X is equal to 3 times the y value, which is 5, minus 18. 15 minus 18 is negative 3. So my x value is negative 3, my y value is 5. That should be the solution to my system of equations. Again, if I just quickly double check that, 5 times the x value of negative 3 would be negative 15. 4 times my y value of 5 would be plus 20. Negative 15 plus 20 is 5. Yep, it checks out. So number 3, again, we are going to solve by substitution, or it wants us to solve by substitution. But notice on this one, you don't have one of your equations saying x equals or y equals. But it is easy to rearrange this top equation and solve it for y, since the y doesn't have a coefficient in front of it. So my first step here is just rearrange this equation And so I am going to say y is equal to -5. And if I move my x over to the other side, plus 3x. Or you could put 3x minus 5. Wouldn't make any difference which order you put it in. Now that I have that top equation rearranged and solved for y, I can substitute here in for my y value on my second equation. So 2x minus 5 times the y value, which is -5 plus 3x, equals 12. Solving that, 2x plus 25 minus 15x would equal 12. 2x minus 15x would be -13x plus 25 equals 12. Subtracting my 25, -13x equals -13, and when I divide negative by a negative, I get a positive, so I get x equals 1. Again, I have to finish solving that, and so I'm going to use my equation that I already solved for y. You could have used either one of your original equations, but definitely once I already have it solved for y, it makes it a whole lot easier. So y is equal to, excuse me, -5 plus 3 times my x value, which we got a 1 for. -5 plus 3 gives me -2. So I got x equals 1, y equals -2. Again, if I just quickly check that, 2 times the x value of 1 is 2. -5 times the y value of -2. Negative times a negative would make that positive 10. 2 plus 10 is 12. Checks out. I have my answers. Second kind here, solving a system of linear equations using the elimination with multiplication and addition. So on these ones, normally you have your equations in what's called standard form, with both the x and the y on the same side, your constant term being on the other side. Your goal is to make opposites either in front of the x's or the y's. It doesn't matter. What you want to do is look for the least common multiple. Since my x's have smaller coefficients, I would probably use my x's. And I think about, okay, the least common multiple of 4 and 3 is 12. I want to make one a positive 12, the other one a negative 12. Since my signs are already opposite, I really don't have to worry about changing any of the signs. So I'm going to take my top equation times 3, which is going to give me the -12, the bottom equation times 4, which gives me the positive 12. If my signs are already opposite, both of these numbers should be positive on the outside because I don't want my signs to change. If my signs are the same, one of them has to be negative because I need to change one of the signs. So multiplying this out, 3 times -4x would be -12x. 3 times 9y would be positive 27y. 3 times 19, let's see, that'd be 27, so 57. On the bottom, 4 times 3x is 12x. 4 times -4y is -16y. 4 times a -17 is going to be negative. 4 times 7 is 28, so I get 68 there. And now notice that I have a -12x and a positive 12x. That's what I want to have happen, is to have opposites in front of those x's so that when I add, they'll cancel out. So now I'm just going to add my two equations together. -12 plus 12 cancels out. 27 minus 16 would give me 11y. 57 minus 68 would be -11. Now all I have to do is divide by my coefficient and I can have this solve for y. So if I divide by 11, y equals -1. Now, I want to find the x value. I don't have one of my equations solved for x, so I just pick whichever equation looks easier. I'm going to use the bottom one because the numbers aren't as big, so it shouldn't make any difference, but that one is the one I'm going to pick up. So I'm going to do 3x minus 4 times the y value, which we said was -1, equals -17. So 3x, -4 times -1 would be plus 4 equals -17. I have to subtract my 4, so 3x equals -21. Divide by 3, x equals -7. Now again, if I want to check my answer, I'm going to check it in the opposite one that I used down here. So since I used the bottom equation to find my x value, I'm going to use my top equation to check. So I'm going to take -4 times my x value of -7 plus 9 times my y value of -1 to see if I get 19. -4 times -7 is 28. 9 times -1 is -9. 28 minus 9 is 19. Yep, it checks out. So those should be my solutions. So number 5, we're solving our system of equations by the elimination method. And if I look at this one, on my y's, my least common multiple of 3 and 6 is 6. So I can make this problem a little shorter than the previous one, because in order to make opposites, I just need to multiply that top equation times -2. So on the top equation, if I multiply everything times -2, I'm going to have -8x minus 6y equals -2. Bottom equation I'm just going to leave alone. Technically I could say I'm multiplying by 1, but I'm saying 7x plus 6y equals 7. So you'll notice again in front of my y's this time I made opposites. One's a -6, one's a +6. So when I add my expressions together, they're going to cancel each other out. So -8x plus 7x would be -1x. -2 plus 7 would be +5. If I divide by my -1, x is going to equal -5. I found my x value. I need to find my y value. This time I think I'll use the top equation. The top equation looks a little easier than the bottom one just because the numbers are smaller. Not that it should make a difference. I'm going to take 4 times my x value, which we said was -5, plus 3y equals my 1, and solve that equation. So here I get -20 plus 3y equals 1. I'm going to add my 20. So 3y equals 21. Divide by 3. Y equals 7. Again, if I just want to quickly double check myself, 7 times the x value of -5 is -35. 6 times the y value of 7 would be +42. -35 plus 42 is 7. Yep, checks out. So number 6, we want to solve our system of equation. On this one, doesn't look like either getting rid of the x's or the y's would be too much easier than the other one. Again, I'm just going to do the x's because my numbers are a little bit smaller there. And so if I want to eliminate my x's, thinking about my least common multiple of 4 and 5, I want to have a 20. I want one to be +20, one to be -20. In this case, my signs are already opposite, so I don't have to worry about that. I'm going to take my top equation. Perhaps I'm going to take my top equation times something. See if I can get my board to work. I'm going to take my top equation times 5. I'm going to take my bottom equation times 4. Again, I don't want my signs to change, so both of these numbers out here should be positive. 5 times -4x is -20x. 5 times 7y is +35y equals 5 times 4, which is 20. On the bottom, 4 times 5x is 20x. 4 times a -6y is -24y. 4 times -5 is -20. So in this case, my x's are opposite. I have one -20 and one +20. They're going to cancel out. 35 minus 24 is 11y. Over here, 20 minus 20 is 0. And when I solve that, 0 divided by 11 still gives me 0. It's okay to have an answer of 0. I want to find my x value. I'm just going to use my top equation. Negative 4x plus 7 times the y value, which is 0, equals 4. Well, 7 times 0 is 0, so negative 4x equals 4. Dividing by negative 4, x equals negative 1. Again, just quickly double checking. 5 times negative 1 would be negative 5. Negative 6 times 0 is 0. Negative 5 plus 0 is negative 5. Yep, it checks out. Seven, 8, and 9 are classifying systems of linear equations from graphs. We're going to do systems of equations that are two lines. And if I have two lines, there are three different ways I can draw two lines. One way is just to have one line that intersects with another line. If one line intersects with another line, it's called consistent because it has an answer. Independent means it has one answer. The one answer is the point wherever they cross. So these will have a unique solution, whatever the point that they cross in is what your answer is. Another way to have two lines is if you have two lines that are exactly parallel to each other. My lines weren't very parallel. If my lines are parallel, they're never going to touch. So the two lines are never going to have anything in common. Those are called inconsistent and will have no solution because they're not going to have anything in common. Third way I could have two lines is if I have one line and my other line happens to be exactly on top of that line. Whoa, my line went crazy. If my one line is exactly on top of my other line, it is called, if my pen would write, I'm going to close my thing. If my one line is right on top of my other line, hopefully you had those other two written down, it is called consistent dependent. And what happens is every single point on the line is a solution to both of my equations because they're really the exact same line. So they're going to say that there's infinitely many solutions. So those were the three ways that you could have your lines. Either they intersect in a point, they're consistent, independent, they're parallel, they're inconsistent, or they're really the exact same line, one on top of the other, consistent, dependent. So on each of these, you're going to have one of each of those, and you're just going to pick them out. So on this first one here, I have two lines that are parallel. If my two lines are parallel, they are inconsistent. They're going to have no solution because my two lines are not going to touch each other. On my second one here, notice I have one line intersecting with the other line. If one line intersects with the other one, they're called consistent independent. Independent meaning one. The solution is the point where those two lines cross. So at 1, 3 is where they cross. You're going to have a unique solution, and you're going to put in that ordered pair, 1, 3 being the solution to my system of equations. So that if I put 1 in for x, I get 3 for y. If I put 1 in for x here, I also get 3 for y. Works in both of my equations. The third one, that's the one where it says line 1 and line 2. I have two separate equations, but if I rearrange my equations, they'd be the exact same thing. Those are the ones that they call consistent dependent. My other phantom writing shows up. Consistent dependent, they're going to have infinitely many solutions because every single point on line 1 is going to be on line 2 since they're the same line. So 8 and 9 going to be the same kind of things. This first one here are the ones where they touch in a point. If they touch in one point, you get consistent, independent. Perhaps you get consistent, independent. There it goes. You get consistent. Whoa, now my board moved. They touch in a point, we get consistent, independent. And the point where they intersect is your solution. So these ones intersect at 0, 3. It doesn't want me to write. There we go. So consistent, independent, unique solution, 0, 3. The next ones, we have 2 lines that are parallel. If we have 2 lines that are parallel, those are the ones that are inconsistent. There, it wrote there. Inconsistent, and will have no solution. So if my lines are parallel, inconsistent, no solution. The third one on this one. Get to the right one, my board wants to hop around. That's the one where I have line 1 right on top of line 2. If line 1 is on top of line 2, they're actually the same line. Those are consistent, dependent, and have infinitely many solutions. One more of those. Go ahead and try to answer number 9 while I'm trying to get the board to write. So on number 9, we have one line and our other line. They intersect in a point. Since they intersect in a point, they are called consistent, independent. The point where they cross is your solution. They cross at 3, -1. Second one on number 9. That's the one where you have one line looks like it's right on top of the other line. If I have one line right on top of the other line, that means that they're actually the same line. Those ones are consistent, dependent, and have infinitely many solutions because every point on line 1 is also on line 2. And the last one of these kind is the one here where we have those 2 lines that are parallel to each other. If we have 2 lines that are parallel to each other, those are the ones that are inconsistent. They might want to be inconsistent. Inconsistent, there it wrote, and have no solution. Since those 2 lines are not going to touch each other, my 2 equations won't have anything in common. (10, 11, and 12), we are solving 2-by-2 systems of equations that could be inconsistent, or that's supposed to say consistent, dependent. In other words, either they're going to have no solution, or they're the one line right on top of the other line. We also will have some that have the unique solution. And so when we solve these, when we are doing these, we're going to do them like we did the ones with the elimination method. We want our x and y to be on the same side and the constant term to be on the other side. And then we're going to see if we can add, if we have opposites, cancel out some terms. So in this case, if I look at this one, I have a negative x and a positive x. They're already going to cancel out. I have 5 and negative 5, which also cancels out. So I get nothing on this side. Over here I have 5 plus 5, which is 10. If I get the answer 0 equals 10, I'm going to have that my system has no solution. Because the board's being difficult, I'm just going to do this one up here on the top. If I have x plus 3y equals 3 and negative x minus 3y equals negative 3, here if I add, the x's cancel out, the y's cancel out, so I get 0. Over here, 3 minus 3 is also 0. If I get 0 equals 0, that's the one that says the system has infinite many solutions. You're going to put it down here on your answer, but I'm going to put it up here. And then what they're going to have you do is solve one of your equations for y. So I'm just going to use that top equation. X plus 3y equals 3. So 3y would equal negative x plus 3. Move my x to the other side. I then divide by my 3. So y is going to equal negative 1/3 x plus 1. Either equation, if I solve it, should give you y equals negative 1/3 x plus 1. They're going to have you type that in over here for the equation. So your top one, you have no solution. The bottom one, the system has infinite many solutions and must satisfy the equation y equals negative 1/3 x plus 1. Number 11, I'm just going to slide it up so you can see both questions here. Again, we're doing the same thing, picking out which is our applicable solutions by solving our system of equations. However, on this first one, I need to move my 2 to the other side. So since that's a minus 2, my board would work. Nope. I'm going to add my 2, so I'm going to have negative 2x plus y equals negative 2 for my top equation, 2x minus y equals 2 for my bottom equation. So when I add these, the x's cancel, the y's cancel. Negative 2 plus 2 is also 0. There's another one of those where you have 0 equals 0. If you get that, it means the lines are the same, so the system has infinitely many solutions. And then I'm going to solve one of my equations for y. I just use the top equation. Negative 2x plus y equals negative 2. So y is going to equal, that's going to become a positive 2x. So y equals 2x minus 2. Bottom equation, if I solve that one, adding those two equations together. This time my x's don't cancel out. I get negative 4x. My y's cancel out. Negative 6 plus negative 6 would be minus 12. So this one is going to solve. I'm going to have a solution to this equation. If I divide by my negative 4, x is going to equal 3. Once I found x, I have to go back and find my y. So negative 2 times my x value of 3 minus y equals negative 6. So this will give me negative 6 minus y equals negative 6. If I add 6, negative y equals 0, so y is still going to equal 0 when I divide by negative 1. So 3, 0 is going to be the solution to that system of equations. It doesn't even want to close. All right, number 12. Number 12 again, we are trying to find what is the appropriate solution. Again, this bottom equation is not in standard form, so I want to rearrange it. I'm going to leave my top equation, x minus 3y equals negative 6. My top equation, I want my x term first. It's going to be a negative x plus 3y equals 6 then. So here the x's cancel out, the y's cancel out, I get 0. If 0 equals 0, the system is going to have an infinite number of solutions. If I get that, I have to solve one of my equations for y. This time I'm going to use the bottom one because it already has 3y equals x plus 6. So all I have to do is divide by my 3. So y is going to equal 1/3 x plus 2. Bottom equations, if I add those together, the x's cancel out, the y's cancel out, I get 0. Negative 9 plus a negative 9 is a negative 18. 0's never going to equal negative 18, so this one is going to be one of those you get no solution. So, solving system of equations with 3 equations and 3 unknowns. If I do this, I want to take 2 equations at a time. In those 2 sets of equations, I want to eliminate the same variable. So I'm going to start off just with my top 2 equations. If I have x minus y plus 2z equals negative 3, and negative x plus 3y plus z equals negative 2, since my x's are already opposite, I'm going to eliminate the x's. In theory, you could eliminate the x's, the y's, or the z's, but it's less work for me to get rid of the x's. So I'm just going to go ahead and add. Those are going to cancel out. I'm going to get 2y plus 3z equals negative 5. Then what I want to do is either use the first equation with the third one or the second one with the third one. I want to eliminate the same variable, so I want to eliminate the x. To me, it looks a little easier to use the first one, so I'm going to use the first one with the third one. So I'm going to have x minus y plus 2z equals negative 3, and negative 3x plus 2y minus 4z equals 1. What I'm going to do there is I want to eliminate the x's. So I need to make opposites. Since this has a negative 3, that has a 1, I'm going to take this times positive 3, make opposites. Everything in the top equation there times 3. So 3x minus 3y plus 6z equals negative 9. Adding those together, the x's cancel. I get negative y plus 2z equals negative 8. Now I'm going to use this equation with this equation. So I have 2y plus 3z equals negative 5, and I have negative y plus 2z equals negative 8. So thinking of that as my system of equations with 2 variables, I can either get rid of the y's or get rid of the z's. The y's look easier to get rid of, so I'm going to go with the y's. I'm going to multiply my bottom equation times 2 so that I have opposites in front of my y's. So negative 2y plus 4z equals negative 16. All right, so when I add my 2 equations together up here, the 2y and the negative 2y cancel out. 3z plus 4z would be 7z. Negative 5 minus 16 would be negative 21. Dividing by 7, z then equals negative 3. I found z. I need to still find the x and the y. First thing I'm going to do is go back to one of these 2 equations and find my y using that z is equal to negative 3. So if I use this top one, I had 2y plus 3 times z, which is negative 3, equals negative 5. So putting negative 3 in for my z. 2y minus 9 equals negative 5. I'd add my 9. 2y equals 4. I would divide by 2, so y equals 2. So I found z, I found y, I still need to find x. In order to find x, I have to go to one of my original equations, substitute in the 2 for y, the negative 3 for z. So I'm just going to use the top one. X minus the y value of 2 plus 2 times the z value of negative 3 should equal negative 3. So x minus 2 minus 6 equals negative 3. X minus 8 equals negative 3. So adding my 8, x would equal 5. So I got answers of x equals 5, y equals 2, and z equals negative 3. If I wanted to double check that to make sure it was right, I would substitute it into either one or both of those equations and double check. I'm just going to check in the bottom one. So negative 3 times the 5 would be negative 15. 2 times 2 would be positive 4. Negative 4 times negative 3 is a positive 12. So 4 plus 12 is 16. 16 minus 15 is 1. Yes, that checks out. So this is going to be my answer. So use 2 of your equations together and then use 2 other equations together. One of them obviously you have to repeat on. Eliminate the same variable. Then you have 2 equations with 2 variables that you can solve. Then go back to your original equations, find your missing variable, and then check your answer. So if we go to number 14 here, solving our system of equations. So at 4x plus 3y minus z equals 0, negative 2x plus y plus z equals negative 8, 3x plus 4y minus 2z equals negative 4. Again, I notice if I use the first 2 equations, my z's are opposite, so I'm going to go ahead and eliminate my z's. And so if I have 4x plus 3y minus z equals 0, and negative 2x plus y plus z equals 0, and I add them, z's are going to cancel out. So 4 minus 2 would be 2x, 3 plus 1 would be plus 4y. Whoops, this was supposed to be equals negative 8 if I could copy my problem down correctly. Negative 2x plus y plus z equals negative 8, so 0 plus negative 8 would be negative 8. So I want to eliminate my z. I want to use my third equation with one of my other 2 equations. I'm going to do it with my second one just because that one has a positive and that one has a negative. So using my second equation and my third equation, negative 2x plus y plus z equals negative 8. 3x plus 4y minus 2z equals negative 4. If I want to get rid of the z's, I'm going to take this top equation times 2 to make opposites. So everything in the top equation times 2, I get negative 4x minus 2y plus 2z equals negative 16. So 2 times negative 2 is negative 4. 2 times 1, that's supposed to be a plus 2y. Good thing I'm checking. So negative 4x, a plus 2y, a plus 2z, and a minus 16. Now, after I have that multiplied out, my z's should be opposites. They're going to cancel out. 3x minus 4x would be minus 1x. 4y plus 2y is a plus 6y. That's going to equal negative 4 minus 16, which is minus 20. So now I'm going to take this answer for my equation and this one, put them together. So 2x plus 4y equals negative 8. Negative 1x plus 6y equals negative 20. Looking at those 2 equations as my systems of equations, I'm going to get rid of the x's. If I get rid of the x's, to make opposites, I just need to multiply the bottom equation times 2. So I would have negative 2x plus 12y equals negative 40. So I'm going to add my top equation plus my new equation. 2 minus 2 is 0. 4 plus 12 would give me 16y. Negative 8 minus 40 would be negative 48. And again, to solve that, I just need to divide by my 16. I believe that's negative 3, but let me just double check here. 48 divided by 16 is 3. So yes, negative 3. I found my y value is negative 3. going to go back up here to find my x value. So I know that 2x plus 4 times my y value, which is negative 3, equals my negative 8, just substituting in the negative 3 for the y. So 2x minus 12 equals negative 8. Adding my 12, 2x would equal 4, and dividing by 2, x equals 2. So I found my x, I found my y, I still need to find my z. I can use any of these three equations. I'm going to use this one here in the middle because it looks a little easier to use. So I'm going to use the negative 2 times x, which is 2, plus the y, so plus a negative 3, plus z equals my minus 8. You can use any of those three. I just picked the middle one because it looked easier to do. So negative 4 plus a negative 3 plus z equals negative 8. That would be negative 7 plus z equals negative 8. When I add my 7, z is going to equal negative 1. Should have used a different color. It's running into my red. So what I came up with is x equals 2, y equals negative 3, and z equals negative 1. Again, just to double check myself, I'm going to plug it into my bottom equation and see if it works out okay. So 3 times 2 would be 6. 4 times negative 3 would be minus 12. Negative 2 times a negative 1 is a plus 2. 6 minus 12 is negative 6. Negative 6 plus 2 is negative 4. Yep, that checks out okay. So those must be my solutions. 2, negative 3, and negative 1. One more of those. I hopefully left myself enough room to write here. Again, I'm solving my 3 by 3 system of equations. If I look at my top two equations, the x's are already opposite, so I'm going to go ahead and get rid of the x's. So I have negative x plus y plus z equals negative 1. I have x plus y minus 2z equals 7. Adding those together, the x's will cancel, so I get 2y minus z equals 6. So I want to look at that. I want to get rid of the x's. Since this is a positive 4x, I'm going to go ahead and use the first one with the bottom one. So I'm going to use the negative x plus y plus z equals negative 1 with my 4x minus 2y plus 2z equals negative 4. I'm going to go ahead and multiply the top equation times 4 so that again I can eliminate the x's from my equation. So negative 4x plus 4y plus 4z equals negative 4. So the x's cancel. Negative 2 plus 4 is 2y. 2z plus 4z is 6z. Negative 4 plus negative 4 is negative 8. So 2y plus 6z equals negative 8. So I'm going to take this answer for that equation, this answer for that equation, and work those two together. So I have 2y minus z equals 6. I have 2y plus 6z equals negative 8. So I have a 2y and a 2y. If I take one of those times negative 1, I can just switch my signs. So negative 2y minus 6z equals a positive 8. So 2y minus 2y, those would cancel. Negative z and a negative 6z would be negative 7z. 6 plus 8 is 14. When I divide, z is going to equal negative 2 then. I found my z. I want to find my y. So 2y minus my negative 2 should equal 6. 2y plus 2 equals 6. If I subtract my 2, 2y equals 4. Dividing by 2, y equals 2. So I found y and z. I want to find x. Again, looking at this, the middle one to me looks a little easier since I just have the plain x there. I'm going to use my middle equation and say that x plus my y value, which is 2, minus 2 times my z value, which is negative 2, should equal 7. So x plus 2 plus 4 equals 7. X plus 6 equals 7. If I subtract my 6, x equals 1. So I got answers of x equals 1, y equals 2, and z equals negative 2. Going to go back and check those, and I like to check it in the bottom one just for fun. So 4 times 1 is 4. Negative 2 times 2 is a minus 4. And 2 times negative 2 is a minus 4. And so 4 minus 4, that's 0. Negative 4 equals negative 4. Yep, it does. So I should have answers of 1, 2, and negative 2. (16, 17, and 18), we are now going to find the determinant of a 2 by 2 matrix. And when I find the determinant of a 2 by 2 matrix, I am going to subtract the cross product. So this is a 2 by 2 matrix because it has 2 rows and 2 columns. I'm going to subtract the cross product starting up here in the upper left-hand corner. So I'm going to take the 4 times the 3 in the lower right-hand corner. I'm going to subtract, and then I'm going to start down here in the lower right or lower left-hand corner and multiply it by the upper right-hand corner. So I'm going to do negative 6 times the 3. So I'm taking this one times this one, that one times that one, and they tell you you're subtracting the cross products. So 4 times 3 is 12. I'm going to subtract. Negative 6 times negative 3 is negative 18. When I do 12 minus a negative, I actually end up adding, and so 30 is the value of my determinant. So always starting in that upper left-hand corner and subtracting my cross product. So on 17, 3 times 6 minus negative 4 times negative 4. So the 3 times the 6, then the negative 4 times the negative 4. 3 times 6 is 18 minus negative 4 times negative 4 is a positive 16. 18 minus 16 is 2. So 2 is the value of my determinant. So number 18, same thing, finding the value of our determinant. We're going to start and subtract our cross products. So negative 5 times 3 minus negative 3 times 3. So that times that minus that times that. So negative 15 minus negative 9 would be negative 15 plus 9. And a negative 15 plus a 9 would be negative 6 for the value of that determinant. So just a matter of subtracting our cross products. And the reason we do determinants is we're going to use them to solve what's called Kramer's rule. 19, 20, and 21, we're using Kramer's rule to solve a 2 by 2 system of equations. Excuse me. So we solve systems of equations by graphing. We've solved them by substitution. We solved them by the elimination method, and now we're going to solve them by Kramer's rule. So Kramer's rule uses 2 by 2 determinants in order to find the value of x and y. The first determinant they just call D. Those values are going to go in the bottom of your fractions on your answers. So determinant D, you're just using the coefficients of your x's and your y's. So 7, negative 6, 7, 4. So 7, negative 6, 7, 4. We are then going to solve those just like on the previous one, subtracting our cross products. So 7 times 4 minus negative 6 times 7. 7 times 4 is 28 minus negative 6 times 7 is negative 42. So I'm going to take 28 plus 42. Gives me 70. So 70 is going to be the denominator of our fractions that we're going to get if we would solve our system of equations. So that I don't forget, I'm going to just put this fraction bar and the 70 underneath so that I remember that's going to be part of my answer for x and y. Now, for the determinant for x, what we're going to do is replace the x column with our answers over here, our constant terms, the 8 and the 7. So the 8 and the 7 go in for your x column. Your y column should stay the same. So that's going to be the 7 and the 4. So this goes here, that stays where it was. Now again, I'm going to subtract my cross products. So 8 times 4 minus 7 times 7. 32 minus 49 would be negative 17. So negative 17 goes up there. I can't simplify my fraction, so x is negative 17/70ths. Over here, this time I'm doing the y determinant. For the y determinant, I'm putting those things here on the end in for my y column. So I'm putting the 8 and the 7 in my second column. The x's should stay as they originally were, so 7 and negative 6. And so I'm going to do 7 times 7 minus negative 6 times 8. 49 minus negative 48, which means I got to do 49 plus 48, 797. So, again, I don't think I can simplify that. Y is going to equal 97/70ths. Double checking my answer. Again, with all my systems of equations, I can plug my answers in and check. I'm going to use the top equation. So I'm going to take 7 times negative 17/70ths plus 7 times 97/70ths and see if I really get an answer of 8. These ones happen to be nice because I can reduce. 7 goes into 70 10 times. Same thing here. 70 goes into 70 10 times. Negative 17 plus 97 would give me 80 over 10. And 80 over 10 is 8. I was supposed to get 8? Yep. Those answers check out. Now, of course, you could use your fraction calculator and double check your answers using your calculator, but since those ones turned out nice, I didn't really need my calculator. Let's look at the next one. If it lets me move the board. There we go. Number 20. Again, we're going to use our Kramer's rule to find the solution of our system of equations. First determinant, determinant D, we're using the coefficients of the x's, the coefficients of the y's. So 5 and 5 go in my x column, 3 and negative 2 go in my y column. Doing my cross product. 5 times negative 2 minus 5 times 3. So this would be negative 10 minus 15, which is negative 25. So again, that is going to be the denominator of your fractions on your answers. So I'm going to have negative 25 down here, negative 25 down there, and I do that right away just so I don't forget to do it. So doing my x value, my determinant for x, replacing my x's with the negative 3 and the 1. So negative 3, 1 go in my first column. My y should be the same, so 3, negative 2. So my cross product, negative 3 times negative 2 minus 1 times 3. This is going to give me 6 minus 3, which is 3. Can't simplify that, so x is just negative 3/25. Doing my y's. On my y1, I take my n numbers, the negative 3 and the 1, put them in the y column. So the negative 3 and the 1 are over here. The x's stay as they originally were, so a 5 and a 5. So my cross products, 5 times 1 minus 5 times negative 3. So 5 minus negative 15 would give me 5 plus 15, which is 20. I have 20 over negative 25, which I can simplify because I can divide by 5, so negative 4/5. So y is going to end up being negative 4/5. And again, if you wanted to check your answers, you could plug them in. I'm not going to take the time to do that, but if you have your calculator, just punch them in quick. 5 times negative 3/25 plus 3 times negative 4/5. See if you get an answer of negative 3. Hopefully you do. Number 21, we're using Kramer's rule to find the solutions to the following systems of equations. So keep in mind that x means I have 1x, and so 1x plus 4y equals negative 9, and 1x minus 2y equals negative 6. My determinant for D, in my x column I have a 1 and a 1. In my y column I have a 4 and a negative 2. So subtracting my cross products. 1 times negative 2 minus 1 times 4. Negative 2 minus 4 gives me negative 6. So negative 6 is the value for D. So on the bottom of these fractions we're going to have a negative 6. For my x value, I'm going to replace the x column with these n numbers. So negative 9 and negative 6 go in my x column. The y coefficients go in my second column. So 4 and negative 2. So negative 9 times negative 2 minus negative 6 times 4. 18 minus negative 24 would be 18 plus 24. 42 if I did that correctly. And if I have 42 over negative 6, I can simplify that into negative 7. So I get a nice whole number answer there. X is negative 7. Finding y. I'm going to replace the y column with the negative 9 and negative 6. My x's should be as they originally were, 1 and 1. So 1 times negative 6 minus 1 times negative 9. Negative 6 minus a negative 9 would be negative 6 plus 9, which is 3. 3 over negative 6 is negative 1/2. So y is negative 1/2. Just for fun, we'll check this one. So I'm going to check it in my top equation. X is negative 7. Plus 4 times y is negative 1/2. So negative 7 plus, here 2 goes in there 2 times a negative 2. Negative 7 plus negative 2, sure enough, is negative 9. My answers check out. And so negative 7 and negative 1/2 are my solutions. Continuing on in chapter 8 here, we're now going to graph some inequalities. So when you graph an inequality, you always start out by graphing it as if there were an equal sign there. So I'm going to graph y equals negative 2x plus 5. Going way back to when we did graphing, we probably decided instead of making a table that just using our slope and our y-intercept is a quicker way to graph. So that's my slope. That's my y-intercept. Plotting my y-intercept first. My y-intercept is 5. My slope is negative 2 over 1. So I'm going to go down 2 and to the right 1. So down 2 over 1, down 2 over 1 as far as you want to go. Now, once I have that, I am going to draw my line solid. Because on Alex, you have to draw a solid line. If you have the less than or the greater than and it doesn't have the equal to, then we need to change it to a dashed line. So we use the little tool that looks like this. In this case, this one's going to stay solid because it does have the equal to underneath, so we don't have to change this one. So we drew our line, we check should we have a solid line or a dashed line. Then we're going to do our shading. So when we look at our shading, we're thinking about the y values being less. The y-axis goes up and down. So if I was going greater, I would go up, less I would go down. What I like to do is find my y-intercept, draw straight down on my y-axis, if I could draw straight, And which side of the line am I on? I'm down here. So this is the side that's going to get shaded. On Alex, you just hit the little tool, click anywhere in that section. It puts a whole bunch of little dots in there and shades it for you. So it should look something sort of like that. Number 23, again, I'm going to graph my inequality. I'm going to pretend it says y equals negative 3x minus 3. So my y-intercept is negative 3. My slope also happens to be negative 3. So my y-intercept is negative 3. I'm going to mark that. My slope, negative 3 over 1. So I'm going to go 1, 2, 3 down and 1 to the right. 1, 2, 3 down and 1 to the right. I have to draw my line solid, but if I look up here, I should have a dashed line. So I'm going to use the little tool that looks like that. I'm going to click anywhere on my line, and when you click on there, it's just going to make it a dotted line instead. So I'm just going to make it look sort of dotted. And so if there's no equal to under your inequality, I should have a dashed line instead of a solid line. Again, I'm going to do my shading. I'm shading less than. So here's my y-intercept. Less than means I'm going down. If I'm going down, I end up being over here on this side of my line. So it looks like I'm shading to the left. I'm really shading down underneath my line, but that's the side I would end up shading. Then, I'm going to pretend that says y equals 1/3 x plus 1. My y-intercept is positive 1. My slope is positive 1/3, so I'm going to go up 1 and over 1, 2, 3 to the right. Up 1 and over 1, 2, 3 to the right. This one is going to have a solid line. I have to draw it solid to begin with anyway, but I'll draw it solid in there. This time I am shading greater than. So my y-intercept going straight up on my y-axis means I'm shading up here above my line. (25, 26, and 27), we are going to graph something that's in standard form. You could go ahead and rearrange it and solve it for y, but you have to remember, if you divide by a negative, you have to flip your inequality sign. So a lot of people make mistakes doing that. So I like to graph anything that's in standard form by finding my x and my y-intercept. So I'm going to put 0 in for y, and then I'm going to put the 0 in for the x. Again, I'm going to pretend this is an equal. So I'm going to take 4x plus 3 times 0. Does that equal or equals negative 12? Again, when we do this, this is 0, cancels out. I divide by my 4, so negative 3 is my x-intercept. So I can put a dot on my x-axis at negative 3. Excuse me, my y-intercept, putting 0 in for the x. Excuse me, geez. All right, so 4 times 0 plus 3 times y equals negative 12. Again, pretending that's an equals. So this is 0. I'm going to divide by 3. Y equals negative 4. And so my y-intercept is at negative 4. Now this should all look really familiar to you because we did this in the chapter we did graphing. Again, on Alex, you have to draw a solid line, but then you want to check and say, oh, I really want that to be dashed. So I use my little tool and change my solid line to a dashed line instead. Now in these ones, you can't just go by your inequality because you didn't go through the process of solving for y. So what we're going to do is test a point. You can test any point on your graph as long as it's not exactly on the line. I like to test the point 0, 0. A, I know where 0, 0 is, and B, it's easy to substitute in. So I take my original equation and put 0 in for x, 0 in for y. So 4 times 0 plus 3 times 0, is that less than a negative 12? Well, why did I use 0, 0? because that makes this 0 and this 0, and so my whole side is 0. That's easy to do. Is 0 less than a negative 12? Is 0 less than a negative number? No, definitely not. So since 0 is not less than negative 12, you do not shade the 0, 0. So I don't want to shade where the 0, 0 is. I have to shade the other side of my equation, so I end up shading down here. Now I really could have tested a point 5, 7, or any point, as long as it's not on the line that I have drawn. So usually I use 0, 0 unless my line happens to go right through 0, 0. Then I have to pick a different point to test. Number 26 then. Again, pretending that's negative x plus 3y equals 6 and finding my x and y intercept. So putting 0 in for y first. Negative x plus 3 times 0 equals 6. 6. This is 0. Negative x equals 6, so x is going to equal negative 6. My x-intercept going to be negative 6. Putting 0 in for x. Negative 0 plus 3y equals 6. That cancels out. I divide by 3. I get 2. 2 is my y-intercept. I've got my x-intercept and my y-intercept. I can draw my line. However, my line should have been dashed, so I have to change it to a dashed line after I draw it. Then I'm going to check on my shading. Again, I am going to test the point 0, 0 since my line doesn't go right through 0, 0. So negative 0 plus 3 times 0, is that less than 6? This would be 0, this would be 0. Is 0 less than 6? Is 0 less than a positive number? Yes. So I do shade the 0, 0. Here's where my 0, 0 is. I want that side shaded, and so I'm shading below my line. One more of those. So we are going to graph 2x plus 3y is greater than or equal to negative 9, pretending that says 2x plus 3y equals negative 9, finding my x and my y intercept. So 0 in for y. 2x plus 3 times 0 equals negative 9. 2x equals negative 9, dividing by 2, x equals negative 9 over 2, or negative 4.5 if I simplify that. Now remember on Alex, to do that, you have to use the little tool that looks like this that says plot a point anywhere. And I'm going to plot the point negative 9/2, 0. And that's going to put my dot at negative 4.5. I'm going to estimate where it is. It's partway between negative 4 and negative 5. So it's somewhere between there. Then I'm going to go ahead and find my y-intercept. So I'm going to put 0 in for x. So 2 times 0 plus 3y equals negative 9. This one's going to come out a little nicer. Negative 9 divided by 3 is negative 3. So my y-intercept, negative 3. Draw my line. Check. Should stay solid because I do have the equal to underneath. Now I have to figure out my shading. Again, I'm going to check the point 0, 0. So 2 times 0 plus 3 times 0, is that greater than or equal to negative 9? So this is going to be 0. Is 0 greater than or equal to negative 9? Is 0 greater than a negative number? Yes. So we do shade the side with the 0, 0. This is the side with my 0, 0. So that's the side that's going to end up getting shaded. And last ones on this sheet are graphing your systems of inequalities. When you graph your system of inequalities on Alex, make sure you do it on your paper first, because when you shade, you only want to shade the section where they intersect, and so you don't want extra shading on your graph. And so I'm just going to do this on my paper, and then I'll erase the stuff I don't want. But on Alex, make sure you do it on your paper and then put it on Alex. So again, I'm going to graph my inequalities. I'm just going to use the y-intercept and the slope to get my lines on there, and then we'll go from there. So on these ones, y is greater than or equal to negative 3x plus 2. 2 is my y-intercept. My slope is negative 3, so 1, 2, 3 down and over 1. It's not quite drawing where I want it. 1, 2, 3 down and over 1. We get the idea. My line is going to be solid, if I could draw straight. Now normally, if I were going to do the shading, I would say y is greater than my line, so I would be going up from my y-intercept. So I'm just going to lightly shade this to remind myself, oh, that's the side I would have shaded. Over here, my y-intercept is at 5. My slope is 2, so up 2 over 1, up 2 over 1. This time my line should be dashed, and so I'm just going to draw it that way. Again, on Alex, you have to draw it solid and change it to a dashed line, but I'm just going to make it dashed here. Again, I am shading greater than. So looking at this line in green, here's my y-intercept. If I go greater than, I'm actually shading this side of my line. But on Alex, what you want to shade is where those two things intersect each other. So since I shaded up and up, it intersected in this little V right between my two lines. So that's the spot that I want to shade. So on Alex, I shouldn't see any shading over on this side, and I shouldn't see the shading over on this side. I should just see the shading in the middle where those two things intersected each other. Only I erased part of my line, so I better get my line back on there. So I'm going to have my solid line here, my dashed line here. I shaded above and above, so I ended up in that top section. Now if these are both greater thans, should end up in that little triangle on the top. If they're both less thans, I'm going to be in the triangle on the bottom. If one's a greater and one's a less, it's one of the two sides, but you really don't know until you do the testing. So you have to check those out and find out for sure. We're going to do a couple of those. So number 29 starts off with y is less than or equal to 2x minus 9. My y-intercept is at negative 9. My slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1, as far as you want to go. This one's going to have a solid line because it does have the equal to. I'm shading less than, so I'm shading below that line, so just keeping in mind that that's the part that I would shade. Here, my y-intercept is at 4. My slope is negative 3, so down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. This one's going to be dashed because it doesn't have the equal to bar. So I have my dashed line. On this one, I am shading greater than. So if I were shading greater than this line, I would end up shading this side over here. So again, you can see on this one, what I actually end up shading is this part over here to the right between my two lines. So I really don't have any shading on here, and I really don't have the shading up here. Again, my line wanted to erase on me. But when you graph it, you're going to put your two lines on there and only shade the part where they intersect. Since one was a less and one was a greater, I knew it was one of the two sides. This one ended up being over here on the right. Last one. I know this was kind of a long homework paper, but there was only 10 topics, so it would have been silly to put 5 and 5 because you needed to do more than that. And so, graphing, my y-intercept is -7. My slope is -2, so down 2 over 1, down 2 over 1. Remember, a -2 could be a negative over a negative, or it could be a positive over a negative. I could have went up 2 and back 1, right? Up 2 minus 1, 2 over -1, it's the same thing. Again, this is going to be a solid line because it does have the equal to underneath. I'm shading greater, so if I'm going greater, I end up shading this part of my line. On this one, my y-intercept is at +7. My slope is 4. 1, 2, 3, 4 over 1. Again, if I want to put more dots and I can't go up and to the right, the opposite of that would be going down and to the left. -4 over -1. So 1, 2, 3, 4 down and back 1. 1, 2, 3, 4 down and back 1. This one's going to have a dashed line. And figuring out my shading, I'm shading less than this line. So less than this line technically would be all this stuff over here. But I just want where those two things intersect. So again, they intersect over here to the right side of my line. I would shade all of this part here. And so you won't see the shading that's down here underneath those two lines, or this part that was above those two lines, just the part over there to the right where the two things intersect. All right, that is the end of chapter 8.